Hello, so the examiners have very kindly given us a speed time graph for a car journey. How kind. The car journey took 100 seconds. Okay, so I'm happy with that. It lasted 100 seconds. And the car travelled 1.75 kilometres in that 100 seconds. So you're happy then that the distance is just 1.75 kilometres. All right. Work out the value of v. So where's v? Oh, v's up there. So in other words, what's the maximum speed that it travels? So what is v? Okay, well, remember our distance, speed, time triangle. So we've got distance, speed, and time in a triangle. So something that looks like that, okay? So what is distance equal to? Well, distance is just equal to speed times time, right? That's how I work it out. So distance, I cover up distance. What am I left with? Speed and time. Okay, so distance equal to speed times time. So let's suppose, just sort of ignore the question for a minute. Let's just have a quick thought experiment. Let's suppose I travel at 10 meters per second, 10 meters per second for 5 seconds. Okay, so let's suppose that I travel for 10 meters per second for 5 seconds. Okay, well, that tells me that my distance, if I just use this formula, my distance, well, my speed is 10. Yeah, my speed is 10. And my time is just 5, right? My time is just 5. So that tells me that my distance should be calculated by doing 10 multiplied by 5. Okay, and that kind of makes sense because if I'm travelling at a speed, I'm travelling at 10 metres per second, which means that every second I'm travelling 10 metres. So in 1 second, I travel a distance of 10 metres, but I'm doing it for 5 seconds. So therefore, I'm going to have 5 lots of those distances. 5 lots of those distances. So how many distances am I going to have in total? I'm going to have 10 plus 10 plus 10 plus 10 plus 10, which works out to be 50. So that makes sense. It's 10 times 5, okay? But I can also draw that on a speed time graph. So let's just draw a quick graph then. Okay, so here's my speed along this axis. So here's my speed along this axis, and here's my time along this axis. So I'm travelling at 10 meters per second for 5 seconds. So if I start at 0 and I end at 5, so here's 0 and here's 5. So that's how far I should travel across. If I draw a little dotted line, and I travel at 10 meters per second. So something that looks like that. So that's 10 meters per second. Okay, well, just out of interest, what is the area of that rectangle? Are you happy that it's just going to be that side, which is just 10 minus 0, so that's 10, right? Times that side, which is just 5 minus 0, it's just 5. Hang on a minute, so it's 10 multiplied by 5. Well, isn't that what I had up here? So in other words, those two things are the same. So what I can say then is that the area under a speed time graph is the distance. Okay? So now if I relate that back to the question, I've just been told the distance is 1.75 and I've been given a speed time graph. So that means that if I find the area underneath that speed time graph, that should equal 1.75. But be careful, because look at the units. I've been given units in terms of speed in terms of meters per second. And I've been given units in terms of time in seconds, okay? But I've been given units of distance in kilometers. I've been given speed in meters per second. So I need to convert this kilometers into meters. That's easy enough. I know that there are 1,000 meters in a kilometer. So therefore I just multiply by this by 1,000. So therefore this becomes 1,750 meters. Okay, and that should be the area. That should be the area underneath that speed time graph. So it's just purely a case of, if I work out the area underneath that speed time graph, that should equal 1,750. Now that looks like a little bit of an awkward area to work out, because I've kind of got go up here and go up there, go up there. That's a trapezium, right? So I can just work it out as a trapezium, or I can split it up into triangles. It's entirely up to you, because if I just split it up into triangles and rectangles, that is how the formula for the trapezium, for the area of a trapezium, is calculated. Okay, so I'm just going to go straight for, well, the area of a trapezium is just half a plus b times the height. So what is a? Well, a is that length there, which works out to me to be, well, it's this length down here, isn't it? So it's the difference between 60 and 20, which is 40, okay? And then b is this length across here. So this is b. So this is a equals that, okay? B will equal that length along there, which is just 100, okay? And what's the height? Well, the height is that bit there, which is v. That's what I'm trying to calculate. So now I've got everything that I need. I can now set up my equation. So I know the area, which of course in this case is just d, so the area is just the distance. So the distance should be equal to half a plus b, so 40 plus 100 times by my height, which is just v. That's what I'm trying to calculate. And I know that my distance is 1,750, so I can replace my d now with 1,750. And then it's just a case of solving that equation, and that will give me what the value of v is. So let's have a look. So first things first, I'm going to get rid of this half. So how do I get rid of a half? At the moment, I'm timesing by half, so let's divide by half. Or another way of thinking about that is just times everything by 2. Because if I times this side by 2, times this side by 2, then I'll times this side by 2. What's a half times 2? That's just 1, right? So what's 1,750 times 2 then? That comes out as, well, do it in sections. What's 1,000 times 2? That's 2,000. What's 750 times 2? That's 1,500. So what's 2,000 plus 1,500? That's 3,500, right? And that equals, on the right-hand side, I've got 40 plus 100, that's just 140, times v. Times v on the right-hand side. So remember, v is what I'm after. Okay, so at the moment, I've got 140 times v. So in other words, I need to divide, so 140 times v, I need to divide by 140 to get rid of that. So I'll divide both sides by 140. Okay, so I'll have v is equal to, so I'll just cancel those things off. So v is equal to 3,500 divided by 140. Okay, so let's set it up, shall we? So we've got 3,500 and we're dividing it into 140. Well, actually, let's set it up like this. So we've got 3,500 divided by 140, cancel off a 0. That becomes then 350 divided by 14. 350 divided by 14. Okay. Can we simplify any further? Can we simplify down any further? So, yeah, let's divide by 2. So 350 divided by 2 is 175. And that becomes 7 on the bottom. Okay. Now I can do my this. So 7 goes into 175. How many times does 7 go into 1? None. Carry across the 1. How many times does 7 go into 17? Well, it goes in twice, doesn't it? That gets me to 14, but I've got 3 left over. So how many times does 7 go into 35? It's 5. So on this left-hand side, so 350 divided by 14, or 3,500 divided by 140, which is what I was doing originally, is 25. So V is just equal to 25. It's just division.